In JavaScript, recursion is a technique where a function calls itself repeatedly to solve a problem. Although it's often slower than the iterative approach in terms of time complexity, it creates a cleaner and simpler code, making it commonly used in data structures and algorithms. Let's take a look at an example. Imagine we want to create a countdown function that takes a number, counts down from that number, and prints each number as it counts. If we used an iterative approach, we might use a while loop saying something like while count is greater than 0, console.log count, and then decrementing the count. If we run this countdown with a starting count of 10, it works as expected. Now, let's implement this recursively. We could log the current count and then call our countdown function again with count -1. However, if we run this, we encounter a problem. It continues indefinitely, resulting in a maximum Callstack size exceeded error. To understand why this happens, it's important to grasp the concept of the Callstack. The Callstack is essentially JavaScript's to-do list. Each time we call a function, it's placed at the top of the Callstack, and when the function completes, it's removed. The issue arises because the Callstack has a limit. If we overload it with too many tasks, it will eventually hit that limit and stop to prevent the program from running indefinitely. And that's exactly what our countdown function is doing. It keeps calling itself without an end. To fix this, we need to implement what's called a base case. This tells our recursive function when to stop. In our countdown example, we can add a simple if statement. If count equals 0, we return. Now, if we run this again with a count of 5, it works as expected. Let's explore another example, finding the factorial of a number. A factorial is the product of all positive integers from 1 up to that number. For instance, the factorial of 5 would be 5 times 4 times 3 times 2 times 1. If we did this iteratively, we could simply use a for loop like so. To find the factorial recursively, we start with our base case. If n equals 0, we return 1. Otherwise, we return n multiplied by the factorial of n minus 1. When we call the factorial function with 5, it works as expected. But let's break down what happens step by step. First, factorial of 5 is called and placed on the call stack. JavaScript evaluates it and sees it needs the factorial of 4 to continue, so it calls that function. This continues until we reach factorial of 0, which returns 1. Then, we work our way back down the call stack, combining all the return values until we arrive at the final result. And that's a wrap on recursion. It can be challenging to grasp at first, but it's incredibly useful in algorithms. If you found this video helpful, don't forget to like and subscribe for more content. Thanks for tuning in, and until next time, happy coding.